Thank you for coming. This is an exciting part of our day today, the Tom Scholl Entrepreneurial Lecture Series. I'll like to invite our President Farvardin, to come up here and say a few words about the Tom Scholl Lecture Series, and then I'll introduce our speaker.
Thank you very much, Mo. Let me start by welcoming all of you to Stevens. Thanking you for taking time from your schedules to come and see the accomplishments, achievements of our students, and to hear a few interesting lectures and learn more about what's happening in this university. I must start by making a very important acknowledgement. The events of today, of which hopefully you've seen some, including the student senior design projects, many of which are on display either in Canavan Arena or in the Walker Gym or in the Griffith Building. The display of the PhD work of many of our PhD students, the presentation of some of the student-driven companies, and all of these efforts, including the lecture that you're about to hear in a few minutes and the presentations after that, they have taken an enormous amount of effort to organize. And I'd like to take this opportunity to thank Dr. Mo Dagani, Dr. Werner Kerr, and many of their colleagues who have been working for an extended period of time for organizing a beautiful event. Thank you so very much for the great job. The second thing that I want to say is that, at least from my selfish and very biased perspective, this is one of the most exciting events on this campus during the course of the year. I feel energized and inspired as I walk from one venue to another venue to see these fantastically innovative projects. I was talking to a young lady who is designing a nose that looks like a human nose, not exactly like mine, but a much more beautifully shaped nose that actually has the ability to smell the kinds of things that we can smell. And it also has the ability to smell the kinds of things that I can't smell, but my wife does. And sometimes actually human beings cannot smell, but dogs do. An incredible thing. I move 2 steps to the other side and I meet this young junior who has teamed up with 2 Stevens alumni who graduated some 10 years ago, and they have formed a company that allows novice investors in the stock market, such as myself, to go on their website and learn from the behavior and the investment practices of the more experienced investors, such as Greg de la Cuela, who's sitting here. And if I choose to learn from Greg's investment style, I can pay him a small fee because I see how he trades. I can pay him a small fee and I can replicate all or a portion of his portfolio. I honestly think this is a phenomenal idea. If you're looking for investment opportunities, I suggest you go take a look at this company, which is called Mimic Trade. And there's a host of another 150 projects at the undergraduate level, 60 projects at the PhD level. It's just most energizing and inspiring. This year, as a result of the leadership of the team that I acknowledged, we have on display advanced projects by our PhD students. This is a new element in this Innovation Expo. And I'm also happy to see so many representatives from the corporate world. We care about reaching out to the corporate world, establishing a closer partnership between Stevens, our education programs, and our research programs, and the corporate world, and I'm delighted to see so many of you here. Without further ado, I'd like to say a word or two about the lecture. This lecture series entitled Tom Scholl lecture series for visiting entrepreneurs is a lecture series that has been established as a result of the generous contribution of Mr. Tom Scholl, a member of the Board of Trustees of Stevens Institute of Technology and a great friend of mine. Unfortunately, Tom is not present here today. He lives in the Washington, D.C. area. He has always been present for this particular lecture series that he cares so much about. but he had some personal engagement and he was not able to be here. I'd like to take this opportunity to thank him for not only his generosity, but for everything else that he does for this institution. I am not going to introduce the speaker, but I would ask Dr. Mo Degani, our distinguished Vice Provost for Research, Innovation, and Entrepreneurship, to come forward, introduce the speaker, and then to just give the floor to the speaker. Thank you all very much.
Thank you, President Farvardin. I too have seen those exciting projects. It's sort of amazing. Every time I see these projects, I become more and more envious. I wish I was an undergrad all over again. I remember my years and my project, and I won't even mention it, when I did my senior project and what I did for senior project. These projects are incredibly well designed and functional and so on. So I also am amazed with the level and complexity of some of our projects that I see. So thank you, President Farvardin. Thomas Scholl, in addition to being a member of the Board of Trustees of Stevens that Neriman mentioned, and a benefactor of Stevens, takes a very personal interest in the achievements of Stevens entrepreneurs and innovators. In fact, I was speaking with Tom this week, and he expressed his sincere regret in not being able to be here. Like Neriman mentioned, he's always here particularly for this function, for the elevator pitch presentations. And also, Tom is the head of the subcommittee for research, innovation, and entrepreneurship of the Board of Trustees. So in that capacity, I interact with Tom all the time. And he's been a wonderful guide on the site for us in showing the vector and directions of where we need to go when it comes to entrepreneurship activities. Nonetheless, he is as pleased as I am to have his lecture series presented by today's speaker, Mr. Sergio Heker. Mr. Heker is a Stevens alumnus. Sergio received his Master's of Science in Electrical Engineering and Computer Science in 1985. Today, he is the founder and CEO of Glisec, a cybersecurity company with headquarters in Princeton, New Jersey, and operations across Latin America. Glisec provides information security products and services to organizations in more than a dozen countries, including the US, Caribbean, South, and Central Americas. Sergio has been involved in internet security since 1985, when he started and operated the John von Neumann CNET. This was the largest and fastest internet network at the time, based at the John von Neumann Supercomputing Center. John von Neumann CNET became the first backbone-based regional network in the United States and the first to offer T1 internet access. It was also the largest carrier of internet traffic in the world. Quite a company at the time. Sergio went on to become the director of John von Neumann CNET at Princeton University, where he focused on building a commercial level network while actively promulgating the NSF process of privatization and commercialization of the internet. This entity was spun off from Princeton University to become Global Enterprise Services. Sergio served as CEO of Global Enterprise Services until 1997. He then formed NextGen Internet, an e-business company operating in the US and in Latin America, and served as its CEO until 2002. In 2003, Sergio formed Glisec to respond to the need of information security, intelligence, and protection in the US and Latin American markets. Please join me in welcoming this internet pioneer and member of Eta Kappa Nu and Stevens Gear and Triangle, which hopefully he'll tell us what that was, Mr. Sergio Heker.
Well, thank you, Mo. And it's a great pleasure for me to be here in my alma mater And I'm going to be telling you my story. I hope you will find it insightful, because it's also a story that relates to innovation and entrepreneurship, which I think it's what we're here for. So I will cover 6 periods in this story, from being a student here until current venture at GLESEC, and in the meantime, the John von Neumann National Supercomputer Center, JVNCNet at Princeton University, Global Enterprise Services, and Next-Gen Internet. It was very exciting for me when I transferred from the University of Buenos Aires, Argentina, to Stevens, and I immediately found that I had so many things that I could do here that I want to share with you. From starting friendships that lasted my lifespan, to access to technology, which I didn't have before, but also involvement in the Student Council, the Gear and Triangle Society, Eta Kappa Nu, and many other things that I could do here, and I took advantage of it all. So I study electrical and computer science, and at the same time was taking my master's courses towards a master's degree and work in a lab as a research assistant. So everything that could be done, I think I was doing it. I started a club and was active in the student council. At the time in which I was graduating, then I decided to ask the then Dean of Graduate Studies for what was his recommendation in terms of my next path, my career. And he mentioned a few things that I found very interesting, because I didn't think he knew me that well. But he said I had to do something that would be entrepreneurship in the technology area and internationally. And that is exactly what I did. I was offered a position at the John von Neumann National Supercomputer Center, which was an amazing place. It was amazing because for many reasons. In one hand, it was one of 6 nationally funded supercomputer centers that Congress had created this program so that the US researchers could be competitive. But at the von Neumann Center, we had 3,000 scientists that were using our facilities. And the facilities included the fastest supercomputer in the planet. It was called the ETA-10. The machine was the first parallel computer. It was had 8 processors, which by then was a lot. The core was immersed in liquid nitrogen, so that would be much faster. So we had a cryogenerator room in our computer room, and it had this other capability where people could do remote computing. Now, of course, we're used to today to connect through the web to a remote server somewhere, but in those days you couldn't do that. So when you compute, you got a lot of paper that you had to analyze. And with ETA-10, the researchers didn't have to actually travel to the supercomputer center in Princeton. They could do the computing from wherever they were. The other aspect of that was visualization. They could visualize, not just get numbers. So for example, we could create a movie, which I've seen, of 2 galaxies colliding. This kind of capability we could do that other people couldn't do. And also important to mention is that our supercomputer was suited for certain kind of science, particularly astronomy and some other sciences that lend themselves to parallel computing. Last but not least was the network, because it's true that people could access this remotely, but they could access remotely by virtue of the network that we had. So here I come. It was a little bit confusing because I went to an interview on Einstein Drive at the Institute for Advanced Studies, and I met with the president of something called the Consortium for Scientific Computing, and that was for a job with a company called 01 Systems and a project called the von Neumann Center. So finally I understood how all of these worked together, And what happened was that 13 universities got together, formed this consortium, engaged a private entity that was specialized in managing supercomputer centers, that was called 01 Systems. And they won this contract with the National Science Foundation for $100 million to build the von Neumann Center. We also received $10 million from the state of New Jersey, so we could have the center physically in the state. Okay. The other aspect of this is that my first day, which was on April 1, and so April Fool's Day, it seemed like that because I went to my first meeting that was like this, and there were the representatives of the National Science Foundation, the state of New Jersey, the 13 university members, and the decision was whether to close down or not the von Neumann Center. So that was my first day at work. The president resigned. An interim president came to salvage the day. That was Dick Spies from Princeton, who was vice president of finance. And so people were telling me, you should go and find another job, something that is more safe. And I thought for myself, yes, I could go and look for something that is safe, but this had all the risk opportunity that I really wanted. And so you will see through my career that I was always involved in risk-oriented, high opportunity activities. And so my decision was obviously to stay. The other aspect is that my first day at work, actually in the office, then I was asked if I wanted to take one or two paths. One was to work with the supercomputers, and the other was to work with the network. And I didn't know much about the network, but it seemed that something that could connect everywhere, everyone from everywhere. And I thought that was a pretty interesting concept, and so I opted for the network, and it was a very quick decision. So my task initially was to learn the military standards for TCP/IP, and I refer to TCP/IP as the protocol suite that makes the internet work. And to learn how to put together the network, because someone already bought all the components, and I will tell you about these components that were a big headache and were shipped to the university members that they were there somewhere. So I needed to find them, put them together, learn how all of these things work, and then operate it professionally. And I had 3 months to do that, because at that same event, the then director at the National Science Foundation said that unless we use internet technology for this network, they were going to pull the plug. So I had to put it together, and it had to use TCP/IP. Okay. So I mentioned, and Mo mentioned the T1, and I don't know how many of you are familiar with what T1 means, but T1 is a telecommunications term, and it comes from the fact that that we used to have telephone calls that took a circuit of 64 kilobits. So the telephone company will get 24 of these together, bundle in something that they call a T1, which is 1.544 megabits per second. So people thought in terms of circuit switching, and this was a network that was packet switching. So that was something completely different, a completely different concept. And it was revolutionary, and it was innovative. So we had this, that people until then were using these 64 kilobit lines, or they were using much lower speed, maybe 1200 baud, 1200 bits per second modems, or even 300 bits per second modems at some point. And now you have 1.544 million bits per second. So you can imagine the leapfrogging capacity that we had. So also at that time, and I will go after this later again, but there were two networks that made up the internet. The internet was two networks, the Arpanet and the Milnet. The Arpanet was the military non-classified network, and the MILNET, that was the military classified network, and they were connected to each other, they used the same technology, and there was something in the middle called mail gateways, which they could disconnect in case that they needed to have this separation. Those two networks were operating at 64 kilobits, so our network was theoretically 24 times faster than the internet networks of the time. So that was the challenge, but also the routers, that you use to connect these things, then were very special routers. They were actually general purpose computers. They didn't exist routers that you can buy today, a Cisco router, and plug it into the wall. So what we had were Digital Equipment Corporation DEC computers that were pretty sizable closets that cost about $100,000 each and could move 100 packets per second, which of course a few years later it reduced to this size that cost a few $1,000s and it could move 10,000 packets per second. But I had to deal with the VAXes. And to connect them, then we used dedicated lines, the T1 lines that I mentioned before. These T1 lines were too fast for the computers, for the VAXes. So we had to lower the speed, use multiplexers. All of these were very primitive. I want to illustrate the technology of then as opposed to the technology that we're seeing today in display in this fantastic event. So we had the lines and we had the multiplexers and we put them together. And then I said, okay, how am I going to make sure that they're running? How am I going to monitor? There were no monitoring tools you could buy. There was not even monitoring technology or protocols designed for monitoring a TCP/IP network extended over several states. So we had to improvise, and that's why we study engineering. And so what we did is we had a file transfer to each of these gateways, and it failed. It will show in a dump terminal, and we will work on that. So there is more about the technology. Now, until that time and later on, people started to build these networks that were like spaghetti networks. What do I mean by that is that I will connect this university, we will connect this other university, which will connect the third university. In our case, the JVNC net was initially like that. So we had lines going from like Princeton, our facility, not the university, directly to MIT. And from MIT, there was a line going to Harvard and another line going to Brown. So if our contact at MIT, Jeff Schiller, was on vacation, that I don't think he ever was, and something happened to that machine, Harvard would have no access to the internet. So that was a problem. We couldn't provide the same quality of service that you will expect today from your internet provider. Okay? So one of the things that I wanted to do when I learned my environment was to find a way to create a service around this network. And later on, as you will see, to create a cost structure and a pricing model for the internet. And so what we came up with was to create a backbone network. And the backbone network basically meant that we will put the main equipment in central locations, and our members, clients, will connect to those central locations. Rather than having a dedicated line from Princeton to MIT, then what we had was that we will connect locally in Princeton, and MIT will connect locally in this case in Boston, and the backbone will connect us in between, but that backbone will carry not only the Princeton to MIT traffic, it will carry everybody else's traffic. In fact, we created a ring so that we'll have redundancy in the backbone, and it became the first T1 backbone network in the internet. Now, where we were going to put these backbone nodes? And the place to put them was naturally at the telephone company's central offices. So we sent this request for proposal to the telephone companies of the time, to AT&T, Sprint, MCI, and nobody responded. So I learned years later that AT&T didn't respond because they didn't want anybody to put equipment that was not theirs at their central offices. And so MCI thought it was interesting, Sprint as well, and a company that we didn't know, a small telco in upstate New York called RCI, decided we're going to do it. And so we created what we call backbone nodal systems. It was our terminology, our architecture, and we placed those at the RCI central offices. And we built the network. And now we have the network, and not only we had this network where we could connect our member clients that are listed here, but then we connected many more people, as I will describe. So I mentioned the consortium, and the consortium included Princeton, Harvard, MIT, NYU, the Institute for Advanced Studies, which is Albert Einstein's place of work, Rutgers, Brown, University of Pennsylvania, Penn State, and the universities of Arizona, Colorado, and Rochester and Columbia. So the initial sites had the T1 lines, but also we had satellite communication with universities of Arizona and Colorado. And everything we were doing was experimental. So a few more examples of that. The VAXes had operating systems, and they were different from each other. Today you buy a Cisco router and you probably don't know what is the operating system of the Cisco router. It doesn't really matter. But in those days they were general purpose computers. So some were running VAX VMS, and some were running Ultrix, which was a Unix operating system, and some were running Berkeley Unix, and so everyone was different. And so there was no TCP/IP or Internet protocols for all of these, like there was not for VMS. So we had to find something, and we found some beta software from somebody that didn't have subnetting or whatever. We had to find a way to make this work because we only had 3 months. But the technology was not mature enough. It wasn't ready, but we had to make it work. Now, regarding the satellite, then we had a satellite dish in our facility, which it's here. A funny thing about this is that the township came and they say you can't have a white satellite dish because everything here has to be color green. And so the vice president that we had at the supercomputer center, Shar Ewan, she says we can't because it's not going to work with the transmission. And of course she didn't know what she was talking about, but the person from the township didn't know either, so we were let use the white satellite dish. Some people were asking if we were actually cooking chicken in the satellite dish, but we were not. We used that to transmit at 256 bits per second, kilobits per second, to Arizona and Colorado, and they were transmitting at 128 kilobits. And what we had on top of that was Ethernet, but not the Ethernet that you have today, Ethernet at 10 megabits per second. And on top of that, we had the Internet protocol. So it was a very suboptimal kind of communication. But since everything was experimental, we were allowed to do those things. So soon after the supercomputer, the von Neumann Center network was built, then 3 other institutions were added to the group: Stevens Institute of Technology, NJIT, and UMDNJ, which stands for University of Medicine and Dentistry of New Jersey. I don't know if it still exists. So, but I just graduated when I started this. I had a graduate degree, but I didn't have experience. So I had to learn on the job. And this is something that for me was a very important thing that I got from Stevens, which was the ability to learn. Because some things that you will have to do at your work, you will not have learned those things. So what you get from this education is really the ability to learn. And so I had to learn how this thing was going to be put together, and I had to learn TCP/IP. And because the computers were Unix, I had to learn Unix, and I was the backup for the Unix system administrator, etc. But my clients, which were the guys at MIT and NYU and Columbia and Penn State, all those guys were running networks which were sizable in their campuses, and they knew a lot more than I did. And so it took me 2 years of solid work to convince them that I had what it took to run this network and earn their respect. So that was something where I felt particularly proud. Now, our network was one of the networks, but we were connected to the rest of the world. And I mentioned the Arpanet and the Milnet before, but there were other networks as well, which I will mention in a moment. Going back to the innovation components here is the Arpanet, which is where we were connected to, and we had an Arpanet node in our computer room, was the center of the internet, which meant that every institution that was had to connect to somebody else had to go through the Arpanet. So there was no connectivity outside of the Arpanet. So, for example, when Bell Labs needed to communicate with Columbia, it will connect through the Arpanet. They will not be able to have a dedicated connection between each other because it would not work. And the reason it didn't work is that the technology was built so that all the traffic will point to the Arpanet, and the Arpanet will know how to send it to the proper location. And that was because there was a protocol that it was called a reachability protocol called EGP that did this kind of work. But when we come into the picture, the NSFNet group, as we were called, then we distorted that. Now we were connecting people outside of the Arpanet, and that created routing issues. And so this EGP protocol was converted into a many-to-many autonomous system routing that is called today BGP, for Border Gateway Protocol. So these are kind of the underlying concepts that most of you probably don't know, but this is what makes the internet work. The other concept of that was DNS. You may have had to configure DNS at some point, but when I started this, there was no DNS. DNS is what makes it so that when you type a name, it will match it to an internet address, so it will know how it's supposed to be sent. And in those days, there was no DNS, so how did we do it? So we had a list, a host table. And so I have my host table, but how do I know the host table of somebody else? So what we had to do every night, we had to download the host tables. So I downloaded the host tables of my 13 and then 16 initial members into us, and we will prepend that into the rest of the internet host table, which was at SRI in Menlo Park, California. And then with this big table, then will be shipped back to our members so people will know how to connect. Until at some point, a guy by the name of Paul Mocapetris developed the RFC, or the request for comment documentation for the domain name system, DNS. So then part of my work became to educate people about the DNS and to convince them to adopt DNS, and then we were operating it for them, at least for our members. So the stevens.edu domain, which was stevens-tech.edu domain, it's something we were managing, the same as Harvard's and MIT's and Princeton's. And we had in our computers, in my computer, was called jvnca.csc.org, the DNS for all of our member clients at the backup. Then the university will have the primary, and our backup was at Princeton and at Columbia. At some point in our history, we got to manage more than 1,000 DNS servers. And some people do that as a business today, but in those days we did it because it was the right thing to do. So the other word that is showing here, SNMP, is what people use today as network management, to be able to monitor the network, the internet. And so when I started, there was no network management, and so we had to improvise until someone by the name of Captain St. John's came up with the idea that if he will use the TCP/IP, ICMP, echo reply messages, he will be able to send a message and get it back and see how long it took to do that, and he called it ping. So now everybody knows ping, and so when I saw that, I liked that idea, and I created the first pinger program that will allow me to monitor my network, because these were things that you did because you had to do it. You needed the tools to do it. So I wrote this program, and eventually it was called NoCall, and for Network Operations Center Online, and people still use it in some places. And so that is a little bit of the technological history of this. Now, there was a structure behind the management of the internet at the time. There was something called the Internet Activities Board, which regulated the technology that will be used, and they will take the request for comments, which were the documents that documented the protocols that make all of this work, that were developed by the Internet Engineering Task Force. That was a closed group, it was a club, basically, of people from certain universities and the military that came up with these concepts. Incidentally, TCP/IP, or the Internet protocols, were created by the Department of Defense to have a survival network in case of a nuclear attack. So that's where this comes from. So that's the IETF, and I had to get special permission to become a member of the IETF in those days, and then I was able to contribute with one RFC myself, which is RFC 509 for directory service. Now, there is something about security here, and we were not that concerned about security in the beginning times, until one day I got a phone call from the supercomputer center that said the computers are slow. And of course, it's not very descriptive. I tried to connect from my apartment using a computer that I had at home. And I just want to break in this to indicate the computer I had at home was the computer that I obtained while being a student at Stevens. This was a so-called a DEC Professional 350, and Stevens was the first university in the country to provide personal computers to the students. So even then, we were in the leading edge. And that's the computer I had in my house. I tried to connect. Indeed, the network was slow. So I had to get dressed and go to work. And it was not the first time and nor the last time. And so what I found out is that we were under attack. It was the first cyber attack on the internet, and it's called the Morris case. So this guy Morris identified a vulnerability that was widely available in every system connected at that time to the internet, and he created a program that will exploit the vulnerability, take over the machine, and then replicate itself and go to other places, and that worm therefore expanded. And the worm could have done many other bad things, but it didn't. But what it did do, it made the computer slow because it was running a number of processes in the machines. That's how we found out. And so what I decided to do was to close the doors. Close the doors meaning that I closed all the ports that connected our network to everything else. And because we had the largest internet network in the world, that is our network, JVNC net, then by doing that, we were able to contain the worm. Okay? Then the FBI came to our supercomputer center to get information. In those days, they were not as sophisticated as today. They didn't know exactly what to get. But the Morris case is a famous case. A year later, I was invited to testify in Congress in the subject of internet security. It's when people started to become aware of the potential concerns that could be on the internet at the time. But again, it was still fairly safe in those days. So I was trying to figure out who was in charge and who was leading or providing the direction for this. And it was certainly not the management of our supercomputer center. Their mission was to run a supercomputer center. The direction came from the National Science Foundation, and particularly Steve Wolf, which was the director at the time of what was called DNCRI, for the Division of Networking, Communication, Research, and Infrastructure. He had a vision of getting everybody connected. And by everybody, I'm not talking only of the thousands of universities in the US, but everybody in the planet. And so the NSF had a number of programs that were developed to do exactly that. And their concept was that they will fund organizations, initially universities, not commercial organizations. And for that, there was a very strict acceptable use policy. Not everybody could get connected to the internet, but the academic sector could. So the concept was the universities will get connected by a grant, and eventually they will start to pay on their own. So because I was a principal investigator for the NSF, then I had to do what they call peer review. So I had to look at other people's proposals, and I realized how expensive it was for the NSF to get every one of these proposals approved. Imagine to get thousands of universities, one proposal at a time. I'm not sure today we'll be all connected as we were. And so I proposed to change that, and I was the first one to put together a proposal of a group of universities, 20, 30 at a time. And that changed the model, and other networks started to do the same, and very quickly we started to get everybody connected. And my focus was the Northeast. So I connected the 100 universities in New Jersey, and all the Connecticut, Rhode Island, some of the New York, Massachusetts, New Hampshire, Pennsylvania. That was my territory. And so Yale got connected through this program, Wesleyan, Boston University, etc., and many others. And what we did was we used our backbone to create a cost structure. In a way, we put price to the internet. We say it will cost you this much, and we created a contract as a service provider. And basically what I was doing was I was productizing the internet. Okay? So in our case then, the National Science Foundation pay us a certain amount of money to connect a university or a group of universities, and the university will have to pay 0 the first year, 25% of the contract the second year, 50%, 75%, and finally they pay their full amount over a 5-year period. And then they were regular paying customers. But my interest was also international. And so you will see that coming over, and I had to do that because I had been told by the dean that I had to do the international part, and so I did. And so I had the opportunity to get a contract with DARPA, the DARPA Defense Advanced Research Project Agency, to connect the United Kingdom to the internet, and with NSF to connect France and Switzerland, and with a group called NordUnet, which was a network connecting the 5 Scandinavian countries to connect the 5 Scandinavian countries and the Quebec Regional Network in Canada, and the CONICET of Venezuela, and the National University of Singapore, and the 6 software technology parks and the Academic Research Network of India. And all of a sudden, we became the largest internet carrier of the time. So interesting to mention that in the case of Switzerland, what we were connecting was an institution was called CERN, which you may have heard of CERN in terms of all the discoveries and atomic concepts. But at that time, CERN had developed a technique to be able to search for documents, and they called that HTML. And of course, you may not realize, but this internet that I'm talking about didn't have a web. There was no graphical user interface into the internet. It was all command language, and the killer application was email. And so at some point later, then somebody thought, why don't we use HTML to create an application to navigate that, and then the World Wide Web was born. Now, I should mention who the other national supercomputer centers were that we're all connected with and that formed the NSFNet. As the NSFNet program was taking longer, then the NSF decided to use the supercomputer centers as the nodes of the NSFNet. And that's how the NSFNet got started. So the supercomputer centers were the Pittsburgh Supercomputer Center, the Cornell Theory Center, the San Diego Supercomputer Center, the University of Illinois Supercomputer Center, and NCAR, which is the National Center for Atmospheric Research in Boulder, Colorado, and of course us. We were the only one not at the university, so we were kind of different, and our staff was all professional staff, and we had the fastest supercomputer, and of course I'm biased. Now, in addition of being connected to the NSFNet and being connected to the Arpanet, then there were other networks, other government networks. One was the NASA Science Internet, the other one was the Department of Energy, ESNet, and the Department of Commerce, the US Department of Agriculture, etc. These were the larger networks, and so because of our geographical location, we were very close to 2 points of access to those 2 networks. One is the Department of Energy had one node in Princeton at the Princeton Plasma Physics Laboratory, PPPL. And so we put a dedicated line connecting ourselves to that. And then the same thing we did with the others. At some point, the Supercomputer Center closed down, but our operation was vital. And so the National Science Foundation helped us, and Princeton University, in particularly the Vice President, R.F. Fuchs, decided to offer me to move the operation to the university, and we became part of Princeton University. And so we basically moved the von Neumann network to von Neumann Hall, which was it's a building in the engineering quadrangle. And we got more organizations internationally connected. And then we started to connect R&D non-commercial to the internet. At the same time, we became part of the New Jersey R&D Council, and that opened us the door to connect all the pharmaceutical and chemical companies in New Jersey. And de facto, we became the pharmaceutical network. And we continue getting the K through 12 and small businesses online. We developed a Google-like search using ways to get a directory for recording for the blind. This is now more talking about content on the internet, something that didn't exist before. So again, all of this has to do with innovation. But at some point, we could no longer stay at Princeton because we had become too commercial to be part of the university. And it wasn't a straightforward thing to go and spin off into a separate company. It was a complicated matter because Princeton doesn't do that. And so we had to basically break ground to do that. And we did. And we created a separate company called Global Enterprise Services. We moved the operation and we basically, I bought it from Princeton. And we became an independent company, the third commercial internet service provider in the United States, and later on the first commercial in Mexico. And we opened subsidiaries in other countries. And what we wanted to do was to be different than everybody else, and how to make ourselves different. Well, one of the concepts was quality. Until then, we were one of the highest quality providers, and we wanted to remain that. Innovative. And number three, international. And so we went to markets that nobody else was there. And so that's exactly what we did. We reached about 1,000 organizations as clients. And then he said, how are we going to continue to finance this? Because our competitors started to grow much faster than we. And not faster because they were selling more. It's because they were getting injections of capital. At this point, Wall Street discovered the internet. And so I thought it would be the right thing for us to do as well. And so I went and I raised financing. Initially, it wasn't capital. What I did is I raised debt. That was a loan, $3 million, which I had to pay 6 months later at a high interest. It was a risky thing to do. But again, that was kind of what I had to do. And 6 months later, I repaid that when we raised $10 million at a pre-money valuation of $11 million. So the company became worth $21 million. And it's something that was started from scratch. And many other things were developed. Important things to mention, we were one of the first ones to have a division focused on interactive media and educational services and some other things. So in this picture, which was taken in Mexico, next to me is Vince Cerf, so-called one of the fathers of the internet, that came to visit us at that point. Other things to mention is I was the first to provide an information security or cybersecurity managed security service. The term MSS is a term that exists in the industry, and I put that name because until that point there were no countermeasures for security. There was antivirus, and then this company, Check Point, was the first provider of firewalls in the market, and I decided to use that as a managed service as opposed to selling the technology. At some point then, I decided to sell part of the business, and it will take a lot more time to explain what it took to get us into that. But the remaining part of the business, which was the international aspects and the divisions we had in the US for interactive media and professional services, educational services, became next-gen internet. And the concept was the network was built, so now it's the next generation, the next thing to do. And so we became an e-business company. And just to explain what NextGen did, as one of our clients, General Motors, we basically did all the online marketing and the facilities management and the security, and basically a full service to keep them as the most visited site in Mexico, this was. And so this is the kind of thing that NextGen did, but at some point the market was getting more crowded, and even though we were a niche player and we were a good player, we had 100 people and we were competing with organizations that had 10,000 people. And so I decided to start here. We're focusing into security, and finally we create a company strictly to deal with cyber security, and we call it Glesek. Incidentally, I did want to use the old name GES, but the guys that bought that name with the network didn't release the DNS name, and so I had to use Glesek, but it would have served the same purpose. So it was an interesting thing. So Glesek was created to help people reduce the risk of operating online, basically. And so we are risk-oriented, and risk-oriented means we're business-oriented, which is similar to what we were doing as part of NextGen, that we were a business-oriented in terms of optimization of building large-scale websites. And so this is kind of a continuous thing. And the other thing is working with emerging technologies, which is what we continue to do, and intelligence gathering, which allows us to provide more information to protect our clients. So as a conclusion, then I want to say this couple of things. Number one is Stevens provides you the tools that you need to decide what is the best path for you. Sometimes people may get afraid to change and of taking risk, and it's not for everybody, but if you do, it's okay as well, and nothing bad will happen for taking risk. So don't be afraid to new opportunities. And also it's about you and what defines you. In my case, was international, emerging technologies, entrepreneurship, and business orientation. Thank you very much.
It's amazing what it takes behind the scene to run a system like internet. During the tour of the projects, I was talking to Sergio, and he said there are many fathers of internet. And then someone mentioned that, yes, but Al Gore wasn't one of them. So when you look at the level of technology that goes on here. So Sergio, thank you very much. I think we have a plaque to present to you. It says, presented to Sergio Heker in appreciation of your contribution to the Thomas Scholl Lecture by visiting entrepreneurs at the Innovation Expo, Stevens Institute of Technology, April 27, 2016. So thank you very much.
Thank you very much. Thank you very much.
Take some pictures.
Sure.
So I noticed that you had Panama as a focus in expanding your business. Why did you choose Panama?
Okay, that's a good question. There were many reasons, and it relates back to Stevens actually. When I was at Stevens, then one of the classmates that I had was from Panama, and so always my initial focus was to go to the larger countries, and this time I wanted to do something different. So I contacted him, and he said, "Why don't you come to Panama and I'll show you." And what I didn't realize is that there was a lot to be done there, number one. Number two is US currency. It's very close to the US, very well connected because there's fiber optic cable from the Atlantic and the Pacific. Everything stops in there. And so communications and all this was a good place to be.
Thank you very much.
My pleasure.
We'll move on to the next one.
My pleasure.